Hello everyone, I am Harsh and today we are going to discuss the 17th problem from CP-31 sheet by TLE Eliminators under the 1100 rating range. So this is the TLE Eliminators website where CP-31 sheet opened, 1100 rating box clicked, and here is the clickable link to your 17th problem. So let's move on to the problem. Let's give it some time to open. Yeah. So here is the problem. So the name of the problem is Hua and Pattern. So the question goes, as Hua has a pattern of size n cross n, each cell is either blue or red. He can perform exactly k operation. In each operation, he chooses a cell and changes its color from red to blue or blue to red. So he is performing exactly k operation. That is the important thing to note it down. Okay. And what he is doing in each and every operation, he is either changing the color of the cell from red to blue or from blue to red. Now, each cell can be chosen as many times as he wants. Now, the question is that is it possible to make the pattern that matches its rotation by 180 degree? Suppose you are Lihua, you have to solve this problem. Okay. So constraint goes as the number of test cases are of the order of 1000, n and k. N is basically n cross n greed is given, and k is the number of operations that you will perform. So n is of the order of 10 power 3 and k is of the order of 10 power 9. Now, each of the next 10 line contains n integers aij, 0 or 1. If the initial color of the cell is blue, then the value of the cell is 0. Else, if the initial color of the cell is red, then the value of the cell is 1. And it is guaranteed that the sum of n over all the test cases does not exceed 10 power 3. You need to print yes if it is possible to make the pattern that matches its rotation by 180 degree after performing exactly k operation. And if it's not possible, you have to print no. So that's the problem for you. So let's understand what actually the problem wants us to do. So the problem says that there is an n cross n grid where every grid has either a color red or a color blue. Now, what you are doing is you are performing k operations, exactly k operations on this grid. In one of the operation, what you are doing, you are changing the color red. If let's suppose the color of the cell is red, you are changing it to blue. And if it is blue, you are changing it to red. Now you can perform an operation any number of times in a cell. Okay, in a cell, you can perform the operation multiple times as well. Basically, you need to perform exactly key operation. And the question says that is it possible that after performing exactly key operation, the color patterns that you are getting that matches exactly to the color pattern if you rotate the grid by 180 degree. So let's suppose this is a grid given. Let's suppose this is a grid given. Let's suppose we have a 4 cross 4 grid. Okay, a 4 cross 4 grid. And some of the cells over here will be colored red. Let's suppose this is colored red. This is colored red. This is colored red. This is colored red. And then this is colored red. Then let's suppose this is colored red. Okay. And let's suppose all the remaining cells are colored blue. Okay. All the remaining cells are colored blue, and it is given that you need to perform, let's suppose this cell is also colored red. Okay. And it is told that you need to perform the value of k given is 3. The value of k given is 3. So first of all, tell me, the value of k is given 3. So you need to perform 3 operations in this particular n cross n grid, right? And the operations should be performed in a way so that when you rotate this grid by 180 degree, the pattern should exactly match. So just tell me, if I rotate this grid by 180 degree, how will the grid look like? It will still be a 4 cross 4 grid, right? It will still be a 4 cross 4 grid. And now if you just try to shade the colors, you will see that whatever was the color in this cell, whatever was the color in this particular cell, that color will come exactly in this cell. Whatever was the color in this cell, that color will come exactly in this cell. Whatever color was in this cell, that will come in this particular cell. And whatever color was in this cell, that will come in this particular cell. Similarly, sorry, yeah, whatever color was in this cell, it will come exactly in this particular cell. Similarly, whatever color was in this cell, it will come in this cell. Whatever color was in this cell, it will come in this cell. Whatever color was in this cell, it will come in this cell. Whatever color was in this cell, it will come in this cell. And similarly, the patterns will match. So your demand is that whatever color was in this cell, that same color should be present in this particular cell as well, right? Because this is a pattern you are obtaining after rotating the grid by 180 degree, right? So what does this mean? Whatever color was in this cell should come in this cell as well. So this cell is what? This particular cell, right? So this means that the color in this particular cell, color in this particular cell, and color in this particular cell should be exactly the same. This is what the question demands. Now, in one operation, what you can do, you can change the color of the cells. You can, like, let's suppose this cell is of color red. So in one operation, you can just remove this red color and change it to blue. This is what you can do in an operation. So the question demands that if you perform exactly k operations, then is it possible that the pattern matches exactly the same if you rotate the grid by 180 degrees? So I hope the question is clear to each and every one of you. So before discussing the solution, let's discuss first of all what's the expected time complexity for the solution. So it is given that the value of n is of the order of 1e3, right? So any solution that works in big O of n squared, or let's suppose big O of n, or big O of n square root of n, or big O of n square log n as well, will definitely give you AC. But if you have a solution that is working in big O of n cube, something like this, or anything greater than big O of n cube, like big O of n cube log n, will definitely give you TLE. So you have to design a solution that works within these time constraints, right? So how we can do this? How we can do this? So this is very much clear that if we have a grid n cross n, if we, let's suppose for an example, take over here a 4 cross 4 grid, so we know that after rotating by 180 degree, let's suppose I name this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's suppose I name it like this. So after rotating by 180 degree, let us see how the grid will look like. If we rotate it by 180 degree, the grid will look something like this: 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, and 4, 3, 2, 1. This is how the grid will look like if I rotate this grid by 180 degree. So what I want that whatever pattern is looking in this particular grid, that pattern should exactly match this particular grid as well. So what I want that color at cell 1 should be exactly equal to the color at cell 16. Don't I want this? That the color at cell 1 should be exactly equal to the color at cell 16. Similarly, don't I want that color at cell 2 should be exactly equal to color at cell 15? Color at cell 3 is exactly equal to color at cell 14. These are the things I want, right? Now, if you just notice, if you are considering zero-based indexing and this is, let's suppose, I comma j, then you want that color of cell I comma j should be exactly equal to the color of cell n minus I minus 1 comma n minus j minus 1. This is what you want. Okay, this is what you want. Okay, so now just tell me, if let's suppose I want that the color of cell 2 is not equal to the color of cell 50, then what operations I will do? In how many operations I can make the color of cell 2 and cell 15 equal? In just one operation, right? I can either change the color of cell 2 or I can change the color of cell 15. So in one operation, I can make, in one operation, I can make the color of two cells equal if they are not equal initially, right? This is how what I can do. Now, what I can do is I can just iterate from this cell. I can just iterate from 0, comma 0 till n minus 1, comma n minus 1. And I can see for how many cells this condition is not satisfied. Okay. So let's suppose in this particular grid, the condition was satisfied for each and every cell. Only for cell 2 and cell 15, the condition was not satisfied. See, 2 comma 15 forms a pair, right? So if the condition is not satisfied for 2, it will not be satisfied for 15 as well. Because what I will do, I will just check this now, that color of 15 should be equal to color of 2. This I will check when I will come to this grid 15. Similarly, when I will be at grid 2, I will be at cell 2. What I will check? I will check that whether color of 2 is equal to color of 15 or not. This is what I will check. So what I can do is I can simply keep a variable count initialized to 0, iterate from cell 0, comma 0 till n minus 1, comma n minus 1. And for every I, comma j, such that color at I, comma j is not equal to color at n minus I minus 1, comma n minus j minus 1, I can simply increment my count. Then do you all agree that once I have done this for all these cells, the minimum number of operations I require to make the pattern exactly equal is nothing but count by 2. Why I'm telling count by 2? This is because the count will be incremented for this 2 as well. Count will be incremented for this 15 as well. Now, since they both form a pair, we only need one operation to make the color of cell 2 and cell 15 exactly equal. Hence, for count equals to 2, I need only one operation, that is basically count by 2 number of operations. So for every pair, count will be incremented twice, but I need to perform only a single operation to make their colors equal, and hence the minimum number of operations I require is count by 2. Okay. I hope the things are clear till now. Now, if you just notice in the question, they have told you that you need to perform exactly k operations. Now, this is very much clear that if, let's suppose I tell this variable as temp, I need to perform temp number of operations finally, which is basically count by 2. It is very much clear if the value of k is lesser than temp, the answer will always be no, right? Because this temp is the minimum number of operations I require to make the pattern exactly equal when the grid is rotated by 180 degrees. So if k is lesser than temp, the answer will definitely be no. What if k is greater than temp? So you will first of all perform temp number of operations. So the number of operations left will be equal to k minus temp. Now just tell me one thing. If let's suppose the number of operations left is equal to 4. Let's suppose 4 operations were left and you need to perform these 4 operations. So can you still make changes, or can you still perform 4 operations such that the pattern will not change when I rotate it by 180 degree? Can I do so? The answer is yes. What I will do? I will just go to any random cell. Let's suppose I go to cell 14. Let's suppose I go to cell 4 and I perform 4 operations on this cell 4. Just tell me, if initially the color of this cell 4 was red, so after performing 4 operations, that is, after performing even number of operations on this cell 4, will the color of cell 4 change? See, initially it was red. Let's suppose initially it was red. I performed one operation, it changed to blue. I performed another operation, it again changed to red. I performed one more operation, it changed to blue. I performed another operation and it changed to red. So after performing 4 operations, red color remained as red and hence there will not be any issue. So this tells us that if we are left out with even number of operations after performing the minimum number of operations, we are left out with even number of operations. So the answer will always be yes. But what if we are left out with odd number of operations? Just see. Let's suppose this was the greed. This was the greed, and I performed all the minimum number of operations, and now the pattern is such that if I rotate the grid by 180 degree, there will not be any change in the pattern of the grid. Okay. Now I am left out with, let's suppose, only one operation. That is an odd number of operation. So do you all agree that if I now perform this operation on any of the grid, so let's suppose this grid was initially having color red and its corresponding pair, that is this cell, was also having the color red. Now if I perform one operation on, let's suppose, this particular cell, so do you all agree that from color red, it will change to blue? And if it happens, then the color of this cell will never match to the color of its corresponding paired cell. And in that case, we would not be able to form a pattern that matches exactly the grid when it's rotated 180 degree by performing exactly k operations. Do you all agree? So, what is the problem that we are encountering? The problem that we are encountering is that every cell is linked up to its pair. Now, both of the cells in the pair have the same color. If I change the color of any of the cell, I have to change the color of its pair as well. And doing so, I will end up performing even number of operations. If I change the color of any one of the cell in the pair, the colors will not match, and hence I can say that if I am left out with odd number of operation, I can not make the color of the corresponding pairs equal, right? But there is a twist over here as well. What is the problem that we are encountering? The problem is in the pair, there are two cells, right? And hence we can't perform and hence we can't make the color of both of the cells equal by performing odd number of operation. But what if we have a pair that have only odd number of that have only one cell in the pair? Can I have this? Yes, I have that condition as well. Let's consider a grid when the value of n is odd. So you can clearly see over here, this middle cell is the pair of itself. And hence, it does not matter how many operations I perform in this particular cell, it will always remain equal to the color of its pair because it is a pair of itself, right? So hence, what we can say, so now we are left out with first we need to find out the minimum number of operations we need to perform. Okay, let's suppose this is count. Count tells us the minimum number of operations we need to perform. then if the value of k is lesser than the minimum number of operations we need to perform, the answer will always be no. What if k is greater than count? So first of all, you perform the minimum number of operations. So from your k, you subtract this count. Now, if the value of n is even, you are very much clear that if the value of n is even, there is no such cell exists, and hence the value left out in k should be an even value for the answer to be yes, else the answer will be no. And if the value of n is odd, you know that you have a cell that is a pair of itself, and hence the left out value is either odd or even, it will not matter, and hence the answer will always be yes. So this is how you can actually solve this question. So let's move on to the code for better understanding. So this is a code. So first of all, I took the number of test cases as input. Then for every test case, I'm taking n and k as input and constructed an array of size n cross n and took an input of the array. Now I initialized my count to 0, went over all the cells from 0, 0 till n minus 1, n minus 1. And if the color of the cell I, j does not match the color of n minus I minus 1 and n minus j minus 1, then in that case, I am simply incrementing my count. At the end, I know the minimum number of operations I need will be count by 2, because for a pair, count got incremented twice, but I need only one operation. Now, if the minimum number of operation is greater than the allowed operation, in that case, the answer will definitely be no. Otherwise, in my temp variable, I calculated the leftover operations that I need to perform after performing the minimum operation, which will definitely be k minus count. If this value is even, then the answer will always be yes. Does not matter whether the value of n is odd or even. Else, if the value of temp is odd, then the answer will be no if the value of n is even. So if the value of n is even and the value of leftover operations is odd, the answer is no. Else, the answer is yes. So this is how you can actually solve this question. So if you just look to the time complexity of each and every test case, so you can simply look that this code runs for n cross n. This code even runs for n cross n. And rest all other code has a time complexity of big of 1. And hence we can say the time complexity for each and every test case would be big of n squared. And if I just look over space complexity, then I have constructed an array of size n cross n, and that is the only extra space that I'm using. Hence, I can say that the space complexity is also big of n squared, which will definitely give you AC. So this is how you can actually solve this question. I hope all of you understood it well. Thank you.